Okay, we're going to spend a little bit of time talking about lenses and how lenses are used in real life to manipulate images. So, if you have, like, for example, a pair of glasses, a pair of glasses on a person is used for a specific reason. And what they do is they put the glass inside is a lens, and depending on whatever they need to do to correct the vision, is what kind of lens they'll put in there. Some people are nearsighted, and some people are farsighted. So some people are really, really good at seeing up close, but not so good at far away. And other people are okay with seeing far away, but not so good up close. And the type of lens that you choose will depend on what actually occurs. And there are two main lens types that we're going to talk about today. The first lens type is going to be a type of lens that curves outward and like this. Okay, and it's going to curve outwards on both sides. This type of lens that curves out on both sides is called a convex lens. And what normally happens with a convex lens is if you have light coming into a convex lens, we're going to say that light is going from the left to the right. And I'm going to just trace the light as if it wants to travel in a straight line, because without being modified or altered in any way, it's going to try to just move in a straight line path. Light kind of works a lot like other things. If you just push it, it's just going to keep going that direction. In this sense, light just kind of wants to go in a straight line. But when it encounters the glass, something happens and it gets bent. And whenever the light gets bent, they tend to move through the glass at a different angle. And then whenever it leaves the glass, it's going to go back to its straight line path, but it's going to be a little bit altered in angle. So it'll still be moving in a straight line. It's just not going to be moving in a straight line at the same angle. Okay, so whenever it goes into the lens, it will not exit at the exact same angle. And if you have a really good lens, what happens is all of the light, whenever it bends, will all bend to one location, and this location is called the focal point. If you have all of the light actually going to a focal point, then it will appear like a normal image, but it might be increased in magnification or decreased in magnification. If you had this lens set up and you moved it to if you moved the image a little bit further away from the focal point, then this would actually make something appear blurry. Okay, and this is normally what happens in people's vision, because if you look at the eye actually kind of curves outwards. So what you're experiencing whenever you look at stuff is you are looking at your eyes are basically one big convex lens. Okay, that's, if you don't know what that is, that's supposed to be an eyeball. Okay, so your eyes essentially work in this fashion, which there's going to be some things that you're not going to like about that whenever I show you some things about it, because here is a example of a convex lens, and this is using a really good lens that I pulled out of a TV. So this was not bought by school. This was actually a really expensive lens. You can see how clear it is on the other side. But there's something wrong. Well, actually, it's not wrong. It's just kind of the way that the world works. If you notice, the image that gets produced is upside down through the lens, and it looks like it's further away than it normally was. Okay, now the reason why it's actually in focus is because my video camera has a setting to where it will automatically change the focus, so it can move that lens back and forth and automatically make the image sharp. But if you notice that the front of the image is sharp, but if you look at the back of the image is not sharp. It is physically impossible to have the entire screen sharp. It can't be done from a lens. There's just no way you can do it. And if you can think of any kind of camera that's made without a lens, let me know. So you can't have, it's like having your cake and eating it too. You can't have a sharp foreground image and a sharp background image. Okay, the only way you could do that is by cheating, by taking two lenses and mashing them together digitally. That could work. But anyway, this image is upside down. Okay, so that means that on the other side of it, you know what? That makes sense, because if we were looking at this, I'll go ahead and I'll erase the eyeball. That's kind of creepy. Um, Here we go. I'm going to get rid of this. So if you have an image over on this side, let's just say that, there's a image of a person over here, then the light from this person is going to hit, and then it's going to bounce or reflect, or not reflect, it's going to transmit through the lens. And when it transmits through the lens, it's going to go past this focal point, which means on the other side, this person is going to appear like they're upside down, because the light from the top of the person is past the focal point, going to go down this direction. So then they're going to appear upside down. And if you look at any convex lens, if you're looking at something past the focal point, it's always going to appear upside down. Okay, and if you try to look at something in front of the focal point, then if you look at it in front of the focal point, it will actually appear magnified. Okay, so if you move to the left of this, so this direction will be flipped and smaller. Can't spell. Flipped and smaller. And if you go on this side of the focal point, usually blurry does occur because of this. Unless you've got a really, really good lens, you will get magnification. It will get larger. It will look larger. Okay, the image on the other side will look larger. Magnification. Okay, let me see if I can show you an example of that. I think I have one that is convex, and it's before the focal point. Let's see what we got here. Yeah, so you can kind of see, it's hard to see because it's fuzzy, but this is actually a convex lens. And if you flip it over to the side, you can see that these images, the cones look a lot larger, and I'm having a lot of trouble actually getting it to go into focus. Notice it's a little bit blurry, but it is larger. Okay, so the image that gets produced by a convex lens before the focal point is actually going to be larger. Okay, I can't really seem to get that focal point with this lens. It's a really small lens, so it's hard to actually get it to work. So you can see the original size of the cone, and then here's the image size of the cone. So whenever you use a convex lens before the focal point, it actually gets larger. If I were to like keep moving it out further and further away, eventually you would actually get it to go flipped over and looking smaller. It's just that this lens was designed to be a magnifying glass. The TV projector lens that I showed you earlier was not designed to be a magnifying glass. Okay? So convex is one big type of lens, and you can get two different effects from it. You can either get it magnified, or you can get it flipped and smaller, depending on what you want it to do. Usually whenever you're dealing with eyeglasses, the eyeglasses are usually meant for some kind of very slight magnification to make it the image less blurry to you. So instead of like moving all this distance over here for eyeglasses, they just move it a tiny bit one direction or a tiny bit the other direction. Okay? And the reason why they do that is because the distance, here's your creepy eyeball again. There's an eye. So the light that travels through, whenever it flips over, the focal point is actually inside your eyeball. Okay, and a lot of times if people are nearsighted or farsighted, they just need to take that focal point and they just need to move it back a tiny, tiny, tiny amount. So the glasses are meant to give you like either to move the focal point just a little bit back or a little bit forward. You don't need to use a magnification that's like 5 meters or something like that. You'll go crazy because you'll look at everything and it'll be like huge. That's what binoculars are for. Okay, the other type of lens, aside from a convex lens, is a lens that's called a concave lens. The concave lens is a little bit different than a convex lens, because a concave, the way I like to think about it, is that the lens actually caves in to the body. So notice how these circles are actually pushing in. That is a concave lens. The lens caves in on itself. Okay, and the light's going to behave a little bit differently in this case because whenever light passes through it, the light is going to bend, but the light bends outwards like this, which is kind of weird. This pattern where the light kind of leaves out this direction, and these are straight lines. I don't know if I'm actually making a straight line, but I'm trying. These straight lines are diverging away from each other. So notice that there's not really a focal point. These lines on the other side of the lens never meet up. Okay, so what happens instead is how you actually form an image on this is the focal point is on the other side of the lens right about here. Let's go and try to get where all these lines match up on the other side, because there'll be a little bit of reflection that occurs as well too, and when that light actually gets over on this side, it creates a focal point. Okay, now this is the focal point for a concave lens. The focal point is, strangely enough, not on the other side of the lens. Because of that, you can't have, let's say that like a person is right here. Okay, what that's going to do is, if the focal point is right here, it's going to make this person appear that they are smaller, but the light from the top of the person is still going to be on top over here. So if I were to like trace this ray would go straight down and it's going to be up. So this person is going to appear like they're upright and smaller from a concave lens. They're not going to flip over in this case. They're just going to be upright, but they are still going to appear smaller. So let me show you an example of that. I think I have a concave lens. Is this the one? I think I accidentally called it convex. Yeah, okay, so here, look. This one, you can tell that I'm going to take my finger and I'm going to move it back and forth. This is concaving, this is caving in. And whenever you flip it over, notice how the image appears smaller, but it's not flipped over. Okay, so when you have a concave lens like this, the image appears smaller than what it is actually in real life. People use this kind of stuff in grocery stores to get, like, you'll use a convex lens to get more of the view than normal. So like if you look at some security cameras, they'll have like a really wide view, whereas if you went and stood in there, you wouldn't actually see everything that camera's seeing. Another good example of convex lenses is stuff like GoPros and those 3D cameras that you have, 360-degree cameras, I think is what they're called, and it really just kind of looks like the entire world is just like curved around them. And what they're trying to do is they've designed the lens to get as much of the area in as possible. That kind of distorts the image and it makes everything look a little bit smaller than what it was made to do. But this is an example of what a concave lens does. Okay, so a concave lens will make you look smaller. If you go on the other side of the focal point, the rays just diverge out and you don't get anything. Like, you won't be able to get an image out of it. So you can only really get a smaller image from a concave lens. You can also flip these over and make them mirrors if you wanted to, but I think I've kind of talked about all I needed to talk about today. So if you've got that, the two main lenses are a convex lens that kind of bulges out and a concave lens that caves in, and the images that they produce on one side and the other side, you'll be pretty good to go. I look forward to seeing you guys next time. Have a great day.